Welcome, Leo Lion students. This is Mrs. Morgan. Today we're going to be talking about prime, composite numbers, and then also prime factorization. So if you are in Show B, then you should notice there are two documents, and we're going to go through both of these. So we're first going to talk about prime numbers and the definition. If you would like, I call these my doodle notes. If you want to kind of fill in the bubble letters here, you're more than welcome. Totally up to you. Just fun part of the notes here. So prime numbers are numbers whose factors I want you to think about, that means multiplying. So any two numbers that we multiply together, that's what we call factors. So 2 times 3 is 6. 2 and 3 are the factors of 6. Okay? So prime numbers only have two factors. They only have 1 times itself. Okay, so let's make a list of some prime numbers. And this list is going to be really important when we start prime factorization. So the number 2 is what I'm going to start with first. We only have 2 times 1 to get 2. There are no other numbers we can multiply to get 2. 3 is also a prime number, so 3 times 1. 4 I'm going to skip over because that's in our composite. We can do 2 times 2 to get 4. So there's more than just two factors. However, 5 is a prime factor, or a prime number, 5 times 1. 6 is composite. 7 is a common prime number, just 1 times 7. 8 we can't do because besides 1 times 8, we can also do 2 times 4. 9 is a common mistaken prime number, but some students forget about 3 times 3, so that doesn't fit this category. 10 is even, so we know 2 goes into it. 11 is our next prime number. We only have 11 times 1. 12 is even. 13 is our next prime number. 13 times 1. 14 is even. 15, we can put 5 into it. 16 is even. 17 is our next one. We could go on and on with this list. If you Google prime numbers, it will come up with an entire list. So there's the start of it, and I'm going to put down here that, or actually I'll put it off to the side here. The list continues. This is not the full list of prime numbers, okay? Oops, and I ran out of room here. Next, we're going to talk about composite numbers. So composite, I put those in red. The prime numbers I put in red because when we do our prime factorization, that's where we're going to stop. So hopefully that makes sense. The green, then, when we do prime factorization, I'm doing the composite numbers in green because we have to keep going until we get to all prime numbers. And we'll talk about that when we get to the next page with prime factorization. So composite numbers mean they have more than two factors, more than one in itself. So something like we talked about 4, you can do 2 times 2, and you can also do 1 times 4. So the number 4 has more than two factors, more than just one in itself, okay? So we're going to continue our list here. We have 4, 5 was on our prime list up there. 6, we can do 2 times 3, and then also 6 times 1. 7 was prime. 8 is composite. 9, I talked about this one when we talked about prime numbers. 9 we often forget about, but 3 times 3. 10 is even, so we can do 2 times 5. 11 is in our prime list. 12, and again, we can keep going and going. This list it really is infinitely long as we go through all the numbers. So again, the list continues. This is not the full list. Okay, just giving you an idea of what prime and composite numbers are. Now, there is a set of what we call neither. They don't fit either category. They're not prime and they're not composite. So the neither list, it means basically it can't fit either one of those definitions. So there's actually only 2 numbers that fit our neither list. The 2 numbers 0 and 1. So 0, we can do 0 times 1, we can do 0 times 2, we could do 0 times 10, we could do 0 times 400. Anything times 0 is 0. So it doesn't fit these categories because it's not just 1 in itself. And numbers who have more than just 1 in itself, well, the whole time you're multiplying it by itself. So the 0 does not work. The other number then is 1. And actually, I'm just going to change this comma to an and sign because these are the only two numbers that fit the neither category. So they are not prime or composite. All right, so now let's talk about prime factorization and how we're going to build that list to get down to all prime numbers that are being multiplied to represent a number. Okay, so prime factorization, a number represented as the product, remember that product means multiply, of only prime numbers. So when we get done, we want to represent, we're going to start off with this example, 72. We want to write 72 as multiplying all prime numbers together. Personally, when I do this, I make a list somewhere of all of our prime numbers. So we made a list on that last page. We have 2, we have 3, we have 5, 7, 11, so on. But then that way, when we work on this prime factorization, this factor tree, when we see any of these numbers, we're done. We don't have to go any further. We don't have to break it down, okay? So I'm starting with 72. We're going to think about what times what multiplied gives us 72, okay? Now, you could start small. 72 is even, so we could say 2 times 36. Now, I'm going to go a different route here. There's a whole bunch of different ways to make your factor trees. I'm going to do 8 times 9, and that gives us 72. Now, look at those two numbers, 8 times 9. Both of those are composite. We can keep going, okay? When we get to a prime number, we're going to circle the primes, and we know we're done. We don't have to break them down anymore, okay? So 8. We're going to break that down. What times what gives us 8? Well, 4 times 2, or 2 times 4 is the same thing. And you notice now 2 is in a circle. We're done. We don't have to break 2 down anymore because that's prime. We can only do 1 times 2, okay? We can keep going then. 4 can be broken down because it's even into 2 times 2. Okay, again, I'm putting those in circles because those are prime numbers. We're done. Okay, now let's keep looking over here. The 9 was composite. So 9, what times what gives us 9? Well, that's our 3 times 3. And both 3's are prime. So I circle them. Okay, when you're done then you can look at all the circle numbers. Now we do want to write them from least to greatest. So I'm going to take the 2's first. So 2, remember this dot I'm putting there, that means multiplication. So 2 times 2 times 2, and then we have 2 3's, so times 3 times 3. So I'm going to put here, we want to put them least to greatest. Okay, now when you get done, an easy way to check your work, what I always do is make sure that this multiplies back to 72. So 2 times 2 is 4, and then we have 4 times 2, which is 8, and then 8 times up here, then we have 3, that's 24, and then 24 times 3 does give us 72. Okay, now we don't have to write all that down. I was just simply checking my work there. An easy, nice way to make sure that our prime factorization is correct. Now, we're going to write these with exponents. We have 1, 2, 3 2's, so we're going to write this as 2 cubed. All right, 3 2's. 2 cubed means 2 times 2 times 2. And then we have 2 3's that are the same, so we can write this as 3 squared, 3 times 3. All right, and we could plug this in and see, does it go back to 72 still? And it will. Okay, so that's one way of doing prime factorization. That's the factor tree method. Like I said, you may not have done that exact factor tree. Maybe you did, you broke 72 into 2 times 36, and you circled 2. And then you would break 36 down, and you keep going until there are all prime numbers that we're multiplying. Okay, another way we can do is called subsequent division. Where we just keep dividing by prime numbers. So here is that list over here on the side of our prime numbers. So we know, like I said, 72 is even. We can divide it by 2. And we're going to work our way down. So 72 divided by 2 is 36. Okay, 36 is even again. So let's cut it in half, divide by 2 again. And 36 divided by 2 is 18. 18 is even again. So let's cut it in half. 18 divided by 2 is 9. Now, we have an odd number, but it is composite because we can do 3 divided by 3. Or sorry, 3 times 3 to get 9. So 9 divided by 3 is 3. Okay? And then 3 we can divide by 3 again, and you want to keep going. When you get to 1 down here, then you have completed your prime factorization. So all of these numbers on the outside here, 2, 2, 2, 3, 3, those are our list of prime numbers. So we would write those down, again, least to greatest, so 2 times 2 times 2, and then times 3 times 3. And notice that we get the exact same result, okay? Again, we do want to combine them when we have multiple factors that are the same. So 1, 2, 3 2's. So we'll write the 2 once with an exponent of 3. And then multiplied by, we have 2 factors of 3. So 3 squared. And like it says there, the exact same result. They both will multiply back to 72. It's just your preference on which method you like best. All right, we will continue practicing the prime factorization and doing more examples tomorrow.